Hello, welcome back to another lesson in Greenfoot. Today's project will be all about image manipulation algorithms. I'm going to do a few with you, but you're going to do a bunch on your own. So look forward to that. The image manipulation algorithms are really important, not just because Photoshop is fun, but they're really important right now in facial recognition software, item detection, all sorts of things where this is being used. So these are kind of cutting edge technology right now. We use it in lots of things. We're going to be looking at some basic image manipulation algorithms and some that are more advanced, but we're still going to keep them kind of simple. But just to kind of get just kind of what's your appetite for learning about what all you can do with a computer and an image. So we'll be using Greenfoot today because it does a very good job of handling images and letting us call methods directly on them. So that's exactly what we're going to do. I'd like you to start with a new Greenfoot project scenario called image algorithms. And you can see mine's just image underscore algorithms. And I've gone ahead and loaded a couple of images into that folder. I'll be sure to attach it to any link that I have. But you can just grab any image you want off of the internet. Just make sure that it's, if you're going to be using it or presenting it on the Greenfoot website, make sure that it's, a Creative Commons, something like that, something where you have the permissions to do that. We definitely want to respect people's copyrights. But these two here are free images to use, so I'm satisfied with that. All right, so the first thing that I want to do is make a new subclass that I'm going to call image. We're going to be working a lot in the Greenfoot image and in the color class from the Greenfoot package. See, there's the images. I've already loaded them in my images folder. So I'm just going to call this image. Okay, and we can actually select one right now. I'm just going to go ahead and select the image of this fall scenery. And so I could pull it out even, and there it is. It doesn't. Yeah, I think it kind of shrinks to the world, right? But there we have it. Let's go ahead and take a look. We're not going to stick with that image. We'll make it to where we can change it, though. All right, so let's go ahead and work on our first image manipulation. The first image manipulation I'd like to do is what's called reflect. Let me write a couple descriptions here in my Java docs. The image class, or this class, is for manipulating images. Author. Well, there we go. At author is Jed Wilshire, and you can use your name. And let's call this version 1.0. All right. I'm actually not going to be using the act method today, so we'll just be calling all of our methods directly on it. All right, so let's start with our very first image manipulation. So I'll call this reflect. Public void reflect image. So we could make an image reflection where the left-hand side and the right-hand side are equal, but I think I'll leave that as an exercise for you. Today what I'm going to do is actually swap the image. I'm going to make the right-hand side go back to the left-hand side. So the first thing I need to do is I need to get the image from my current actor. So I'll just say Greenfoot image, which is the name of the class we're using. I'll just call it img. And the actor method is called getImage. That's the method that we use. All right, so now what I'm going to do is I'm going to loop through all the pixels in this image and try and manipulate them. So the pixels, we need to be able to access specific pixels. So let me pull up the Greenfoot image class. Here it is. We have several different constructors. As you can see, we can construct it with a string of a file name, or we can construct it with another image. That'll be important to us later. We have lots of different ways that we can draw on a blank image. But what we're going to be using mainly today is getColorAt and setColorAt. This allows us to get a color at a specific pixel and to set the color at a specific pixel on our monitor. So we'll also need to use the color class. So that's why I have that up as well. So what we're going to do is we're going to loop through all the x and y of the image. So I'm going to say for int, and I want to move like this. I want to move left first and then down. So like a typewriter, like that. It wouldn't actually matter in the effects right now, but I think it's a good practice to understand that how we control that. So the outer, we're going to have to do 2 loops. One loop controls moving left and right. The other controls moving down. So the one on the outside is one that will be done last. So I want to move all the way across before I move down. So I'm going to put this on the outside. I'm going to say for int y equals 0 is the first spot in this image. And I will be looping all the way through the image's height. And that's get height. Watch this. So -1, maybe. Actually, no. I can just say, we will need that. Y less than is what I need to say. Excuse me. As long as I say less than, it won't go too far. I could say less than or equal to, and then I would need the -1. So no, we'll just say less than image height. Because remember, if we have a picture, let's say our picture was 10 pixels, the top pixel is actually got a y-coordinate of 0, so the bottom pixel is 9. That does make 10 whole pixels. That's just the standard way of doing it. It'll also be following our standard conventions that the numbers get bigger for y as they go down, so not like algebra class, but like computer science class. And we're going to be going 1 pixel at a time, so I'll use y++. And next I'm going to say for int x equals 0, x less than image.getWidth x++. All right, so I've got a loop now that moves horizontally through the entire width of all the x's in a specific row of the picture. Then, once it finishes that row, it goes to the column and moves, in this case, by moving up a y, moving down. So we're going to move every pixel just like that. And you can imagine that in some of these pictures, there could be just tons and tons of pixels, right? But it's a computer, so it'll go fast. But even then, there could be some load time, but that's okay. All right, so what are we going to do? We are going to get that pixel. And the pixels are stored in a class called color. So I'll say color pixel. And what I want to do is I'm going to get the pixel on one side of the image and reverse it with the pixel on the other. So let's get the pixel that's on this side of the image first. That will be image.getColor at x, y. There we go. That's going to return the color at x, y. Now what I want to do is I want to set the color there with the color on the other side of the image. Oh, you know what I just realized? This is too far. If we are going to go all the way across our image, if I was to flip the left and the right like that, like that, like that, and go all the way across the image, if I went all the way across, I'd end up flipping everything that I flipped back again. I should really only go across half of it. Yeah, let's let our x's only go across half of it. All right, now that's the pixel that we're at. I want to set the pixel there with the pixel on the other side. So I'm going to say set color at, and I'm going to set the color that is at x, y with the color on the other side. So I'll say image.getColor at, and I have to say image.getWidth -1. There's where I need that -1. That is so important, because if you try and get a color if you try and get the color at the width of the image, you will get an error. -x, y. So let me explain what that means. So this is going to get the color, right? And the y coordinate is the same because we're just flopping horizontally. But get image width -1 is the last pixel in the image horizontally speaking. So when x is 0, we're on the very far left, and image.getWidth -1 x would actually just be image.getWidth -1, so that would be on the far right. But you've got to have that -1 in there whenever you're manipulating things like this. Okay, I like that. Now, once I've done that, I've actually taken the right-hand side and copied over to the left. And so if I wanted to get like a mirror image where like the two sides were exactly the same, then that's what I would do. But instead, I want to actually flip it. And that's why I needed this temporary pixel, or else I would have just written over it. So now that I've got that, I'm going to say image.setColorAt. And I'll be setting it at image.getWidth -1 minus x, comma y, comma pixel. All right. So now that's going to allow me to reflect the image. So I think that's probably it. Let me just check my notes to see if there's anything else I wanted to do on this one. Yeah, I think that's just about it. So I'm going to go ahead and compile it. We're just moving around pixels, not really doing a whole lot of manipulation here. All right, so I'm going to go ahead and I'm going to go to my world here, and I'm going to make this a little bit bigger. I'm going to make it 1000 by 600. All right. All right, and let's drag out a new image, and there we go. Now, if I right-click on it, I have some options. I can reflect my image, and there it is. It's reflected. All the pixels got flip-flopped. It's pretty neat, right? All right, I do want to add a little bit more functionality to this program before we go any further. First thing I want to do is I want to go to the My World class, and I want to make a constructor, and then I want to go to the My World class and set that up. So for my constructor, I want to say public image string image name. Actually, let's just call it file name, because that's exactly what it'll be. And what we'll do is we'll go ahead and say set image to a new Greenfoot image with this file name. All right, another thing I want to do is I want to keep a reference to the original image. So I'm going to say private, make an instance variable, Greenfoot image. So it's a lowercase image, so not the class image. Actually, let's not call it that. Let's call it original. That'll be good. Original. And then I'll say original equals get image. Okay, now I want to talk about why this doesn't work. But this is actually bad. This doesn't work. But we're going to talk about why in just a second. Let's pretend it did work. Well, now that I've got that, there's something I want to be able to do. I want to write a method that we can call to go back to normal. So I'm going to call this revert. And what we're simply going to do is say set image to original. All right? The logic makes sense, right? I kept a copy of the original, and then I'm going to set the image back to it whenever I need to. All right, now that we've added this constructor, we're going to need to go to the My World class and do that. So here's where we're just going to put our file names in here. This will allow us to try different images that we want. So I'm going to make a new object. So I'll say add object at, or just no, add object, excuse me. I'll be adding what? A new image. And that new image for me is going to be, it's fall.png. And I'll be adding it to the world's width divided by 2, comma, the world's height divided by 2. I just, that way it kind of gets centered. Okay. So we should have the image appear as we compile. There it is. All right. I'm going to go ahead and reflect the image. And I could just simply reflect it back, but instead I want to check revert, and it didn't work. Of course, I told you it wouldn't work, but let's talk about why it didn't work. So you have to understand that this variable original, it says it's of type Greenfoot image, but it's not a Greenfoot image. You need to understand that. When you have a reference type, you do not keep the object, you keep a reference to it. All right, so keep that in mind. Let me pull up my paintbrush, and maybe I can kind of draw you a little bit of an imagery of what this looks like. So the computer's memory, when we make primitives, we store exactly that primitive in the variable. All right. So, but it's not that often you get to work with primitives. So if I have a Greenfoot image, okay, I'll just call it GFI, and I make it, that's somewhere in the cloud of the computer. Not the cloud, like I picture this memory cloud. They actually call it the memory heap, okay, or the object heap. It's somewhere in there. It's not in one specific location in my memory. I mean, how could it be? It's made up. It's pretty complicated. It's an image. It's got color. Each color's got three different primitive int values alone. So it's got tons of different primitive values and other object values that it links to, including a name, a file name, all sorts of stuff. And that's very complicated, and it certainly doesn't fit into one little variable name. Well, when I say original gets this, when I say get image and I store it into original, what I'm storing there is a reference, a set of instructions for the computer to go and find the object in the memory heap, a set of directions, right? Like, turn left at the old mill kind of thing, right? So here we have the image that we have set for our image object, right? We have the same, that's the image, the original one that we get when we get image and all that stuff. And it's pointing to this thing. And then when I say original points to it as well, later on when I did all my converting here, I changed this object here. This object changed. And so original is still pointing at that same newly changed object, right? So what I need to do instead is that I need to make original point to a different image. And this is something that is going to be important when no matter what we study. This idea of like keeping track of and making, deep copies of things. So instead, what I'm going to do is I'm going to make a new GFI, a new Greenfoot image, and copy the contents deep within there. So whatever the contents are there, I'm gonna copy it over. Luckily, we already have that constructor. So if we go back and look at the Greenfoot image class, you'll notice it says create a Greenfoot image from another Greenfoot image. Greenfoot image, Greenfoot image. You might look at it and be like, why would I ever call the constructor for a Greenfoot image with a Greenfoot image? Just like, why would I make a new Greenfoot image? Why would I make a Greenfoot image if I already have one, right? But it makes a true deep copy of it, where I can manipulate this one without changing that one. So that's what we need to do. Let's go back to our class and do that. So instead of saying get image, we're going to say new Greenfoot image. See that keyword there? I like that from Java. New. It's telling me make this a new reference. There we go. Much better. So we get the image and make a new image out of it. Now it's going to work. Let's check. All right. I'll reflect it, and if I call revert, boom, right back. Pretty nice, huh? Okay, I'm going to do a couple more with you, mainly because this is fun, and then you're going to get to work on your own. So let's talk about what else could we do. Well, we've got the reflect image. I want to talk a little bit about pixels, because you'll be doing a lot of work with this specific RGB values. If you take out a microscope and you look like really close to your computer monitor, you'll notice that each pixel is actually 3 bands of color. There's a red, a green, and a blue, and that's it. I mean, if you look closely enough, this whole monitor, this whole image that you're seeing right now is just a series of little ribbons of red, green, and blue. And yet your eyes put that together into a single color based on how strong each of those are. And they vary from 0 to 255, which gives you 256 as a range of numbers. So that's what we're going to be dealing with, is those numbers now. I want to make a method to grayscale an object, okay? Now, when I grayscale this image, though, I don't want to just set everything to the same color. I want to make it relative gray so that we can still see things. Otherwise, we just look like a gray blob. So let's call this grayscale. So what makes something gray? Well, a color of gray occurs when the R, G, and B are the same value. And we have a darker gray as we get closer to 255, 255, 255, which is actually pure white, as opposed to 000, which is all black. So we're going to be setting our R, G, and B values to the same value, but we'll be using an averaging. So let's take a look at that. So I'm going to once again get a copy of the current image that I'm working with. And this is, I call it a copy, but I'm actually just getting an additional reference so I don't have to say get image every time. Oops, I just want to be able to say IMG. Just going to save me about, 6 symbols of typing each time. All right, so once again, I'm going to loop through the entire picture. This time, I'm not going to stop at halfway on the width. I'm going to loop through the whole thing. Int y equals 0. We'll be looping while y is less than image dot get width. Oh, get height. Y plus plus. And I'll say for int x equals 0, x less than image dot get width, x plus plus. And first thing I'm going to do is I'm going to get the red, the blue, and the green of the color. So, well, let's just go ahead and get a color. I'll call it pixel. So I'll say get color at. Oh, that is a method that belongs to the image. Image.getColor. If I just said get color at, that would be if that was a method in my actor class. Remember my subclass of actor right now. But it belongs to image. Get color at x, comma, y. And now they're ints. Let's go back and look. By the way, the way you find this is you say, here you go help, Greenfoot class documentation. But let's go back and look at our color class. So in the color class, you notice they have some preset colors that we can use, and they're static. So it would be color.blue, color.gray. But we also have a constructor where it takes in RG and B. This is RGB and alpha. Alpha is like how transparent it is, and we're not working with that right now. But we've got get blue, get green, and get red, which are ints. They are primitives. So we're going to say int RGB. Red is, again, it belongs to the image. Oh, no, it doesn't. Does not belong to the image. Does not belong to the image. Why would I say that? I can't believe I said that. What is this class? Color. It belongs to the color. Notice they're not static, so I don't say color.getBlue. These are static fields, okay? And I would say color.blue because that's just a way of being able to set the color to blue. But these are methods. They are instance methods. See that? Instance, no static. So you have to have an instance of this class. Okay? So my instance of the color class is pixel. So I'll say pixel dot get red. And it makes sense because it is a pixel. I got the color at something. That's the pixel. Then int RGB. So green is next. Pixel dot get green. And blue. Pixel dot get blue. All right. Now that I've done that, let's get the average. So the average will be taken by red plus green plus blue and dividing by 3. Keep in mind this will be an integer division, so it will throw away any fractional amounts. But we need that because the color constructor, if you notice, takes ints for the parameters. So we can't have floating point numbers. So it's good that it does that. All right, I'm going to make a new color, which I'll call gray, equals new color, and then going to give it the average for the red, average for the blue, and average for the average for the red. Then I do green. This is the blue. So if I wanted to say keep one of the colors the same, like keep the amount of blue the same, but gray out the red and green, then I would go ahead and just put the blue right back here. All right. So now we've got that. Let's set the color there. Okay. So here we go. I need to on the image. This belongs to the image, and it's set color at. And I'll be setting the color at x, y, and we'll be giving it the color we just made, gray. We could have also just combined this in one line by copying and pasting that right there. But okay, I hope you're excited as I am. Let's see what happens. Neat. And notice how you can still see it though, because they're varying scales of gray based on the average color. We can reflect the image, but that reflection will be in gray. But we can always revert. I do have another image, so let's check it out. If I were to change this to fox, I got a pretty cool picture of a fox I'd like to share with you. Now, I'm still going to have that picture of the forest here because that's our default that we said earlier. But there it is. There's my fox. And I like reflecting my fox. Isn't that cool? Grayscale my fox. All right. That is cool. But I'm going to do a couple more. So the next thing I want to do is I want to talk about some blurs. Okay, let's do some blurs. So there's a Gaussian blur effect, and the Gaussian blur is actually a pretty complicated algorithm, but it uses the Gauss's formula, which is really important in statistics. And it's gonna blur the image. Now, it sounds weird that we would blur an image, but blurring the image is actually quite useful. For example, like making background look and all sorts of different settings. So let's do a Gaussian blur together. This one's not too bad because some of these you have to actually check to make sure that you are not that you're not going outside of 255 and 0. So some of the assignments I'll give you, you're going to have to check for that. And you know, if the number results in something bigger than 255, then you have to set it to 255. If it's negative, you got to set it to 0. But let's do a Gaussian blur. So I'll just put that right here. So public void Gaussian blur. Okay, so the Gaussian blur is going to be a little more complicated because we're going to need to use the original image all the while that we're manipulating another one. So we can create a brand new image and then manipulate it if you want, or we can manipulate the current one and then keep our original. What I'm going to do is just make a new Greenfoot image that I'll call GB for blur. Okay, so I'm going to say Greenfoot image GB equals new Greenfoot image, and I assume that we have the rights to make it with a certain width and height. Yeah, see, I can make an empty image with a certain width and height, so it'll basically be just like a canvas. And I'm going to use let's go ahead and get our current image, though, as well. So I'll say Greenfoot image img equals get image. That just saves me a little bit of typing. So I'm going to say image.getWidth and then image.getHeight. And so the reason why I'm doing this is because we're going to be using a blur effect. And when you do any kind of like 3x3, or I think the bigger one's really a 4x4 or even a 5x5 matrix of it. Whenever you're doing these blur effects, you're going to be looking at pixels around you, and you want to make sure that you don't change one pixel as you go through and then later on use that change value. So you have to keep a copy of the original image as you're constructing the new one. All right, so the Gaussian blur looks a little bit like this. Let's just add some notes. This is not the true way of doing it. This is not the final way. This is just a simplified version. So the real values are decimaled and things like that. But But what we do is we're trying to find the value at where the 4 is. So the image right in the pixel right in the center gets the biggest weight. So it gets a weight of 4. And then the other pixels we're going to take are the one over all the way around it. And so this corner pixel only gets a weight of 1, but this one gets a weight of 2, 1, and these are the impact that it has on it. So we're going to be taking a little bit of the value of the colors and the pixels around us. So they won't be each it'd be impossible to have 2 pixels that were completely independent of each other because we're putting some sort of dependency upon them. Because this pixel is going to affect this color, and then likewise when we come over here, the pixel to the left will affect it as well. So we're building this dependency, which gives us that blur. Now, if you add all these up, you'll notice this is 1 plus 2 is 3, plus 2 is 4. This is, and then you have 2 plus 4 is 6, plus 2 is 8, so that's 12. And then we got another 4, that's 16. So there's a total of 16 numbers here. And we're going to have to keep that in mind because I need to scale down my calculations by that value. All right, so here comes our loop. We're going to do the whole thing, all right? We're going to go from int y, starting at 0, y less than, well, actually, you know what, though? Let's talk about that. If we start at 0, won't we go out of bounds? So let's not start at 0. Let's start at 1 row down. So we're going to start y equals 1. We're going to do y less than img dot get height minus 1. So we're actually going to not go to the bottom row here. We could go to the bottom row and do that, and then you would just ignore this bottom row here and only use the top. But for now, let's just blur the interior. Okay? I don't think we'll really be able to see the difference in 1 pixel anyway. All right, so there we have it. And then I'll say for int x equals 1 as well, x less than img.get width minus 1 x plus plus. Okay, let's go ahead and put my curly braces now. Now I'm going to get all the pixels in this kind of rectangular 3x3 area and get their value, but I need to do it then I need to do the calculation though for red, green, and blue. Okay, so now we've got the loop set up. We're gonna go through the image, but let me go ahead and put that on there. What that's going to look like. Okay, so we've got this image here. Okay, we're going to actually skip the first row. So just imagine that we could actually see in that. We're going to skip the first row and column, and we're going to loop through the whole thing. What I need you to do though is I need you to loop again, doing this loop where you go through each one of these. And look at the pattern for how you can figure out how you can calculate the amount of red and the amount of blue and the amount of green. So I would say like int red equals 0, int blue equals 0, int green equals 0. So you got R, G, and B. Yeah, it should be R. I like to keep it in order so I remember. RGB. I have to say it out loud like that to remember. All right, so you're going to have to do a loop. And at each spot of the loop, you're going to have to add to your red, your green, your blue values. You know, when it's here, you have to multiply. You don't multiply anything. You just add the R, G, and B with that pixel's R, G, and B. Then you do this one here. You have to multiply by 2. And this one here by 1. And so then 2 and then 4. So there's different ways you can figure that out. Let's talk about this one. You know, this pixel here is 0, 0. This pixel here, you know, I would think about it in the loop. When you're doing your loop, you're starting at 0, 0. This is 1, 0. This is 0, 1. This is 2, 1. This is 1, 2. So there's a little bit of a pattern there that I think you can figure out that will help you. You know, here was 0, 0. Here was 2, 0, 0, 2, 2, 2. This was row 0, column 1. So that's 0, 1. Sorry, 1, 0, 0, 1, 2, 1. And this is 1, 2. Do you see the different? You see the relationship there? It's kind of like an odd even thing. So I think you can use that. So I want you to write that loop. It's going to look something like this. For int like I equals 0, I less than 3. Then you'll have to do for int k equals 0, k less than 3. But I want you to do this, okay? So that's it. And I'm going to show you kind of the effect that I get so you can see it, but I'm not going to give you the answer. All right. And then but I got you a good setup here. Calculate the R, G, and B values. Don't forget that when you get them, make a new color and paste that pixel there into our original. So after you've done this loop, you're going to have to, not our original, but our Gaussian blur image. So you'll have to say GB dot set color at. You'll have to give it the X comma Y, and you'll have to give it the calculated, you could just say new color, red, green, blue. And then when you're all done with this algorithm, lastly what you have to do is you have to say set image GB. Okay, so the rest is up to you. I'm going to post on my website, I'll post some additional algorithms I want you to do. Good luck, but this is an important thing for you to struggle through yourself. Okay, so before I send you off to do that, though, I wanted to go over what you should expect from the Gaussian blur. So I have our Fox image up here. I did tell you something I want to amend. Instead of doing that inner loop, so we have a loop within a loop that's moving through all the pixels, and then we have another loop that's actually going through a 3x3. I said loop from 0 to 3. Actually, when as I was writing it, I hadn't written in a while. I found that it was easier since we're talking about that main pixel being the center. I actually found it easier since, whatever value x, y you're at, that pixel, I'm going to the left and up. So I actually did a loop from -1 less than or equal to +1 for an I, and for k less than -1 to less than or equal to +1. I was able to save myself a little bit of writing by realizing about the odds and evens things I was going over with the position, and that's still true. I took the absolute value first of their sum of the indices, and that would allow me to do it. You don't have to do it that way. It's not that long. You can use ands and ors, and you can cut down the coding, or you can just code a whole lot if you need to, I guess. But I'm just kind of fascinated with trying to make things short, but sometimes that's not that important. Well, anyway, here's my Fox. I am going to blur my Fox. I have blurred them one time. I can do it again, although there's kind of a diminishing margin, marginally returns here. But I'm just blurring and blurring and blurring now. Notice that there is a little bit of a delay. I mean, this is a pretty long algorithm. We have to loop through every single pixel, and then every single pixel you have to loop through 9 more pixels. So it's pretty slow. And if you use even the fuller Gaussian blur, it goes even more than 3x3. You can look it up and use it if you want. And we could just keep doing this, but eventually it's just not gonna. So this is kind of blurred now. Let's revert back, and I think you'll see that immediate change. It's pretty dramatic, isn't it? Just how much that we had gotten it blurred. You get so used to it being blurred. So anyway, well, that's the effect. Have fun with that, and I'll see you in the next video.